Good morning all, this is Yogesh, URK17CS077, and in this session of video we will see how the doubly linked list is implemented in C++ programming language. So as we know that doubly linked list is more efficient than singly linked list, the only drawback of doubly linked list is that it uses two pointers, one for the head and one for the null. That is its drawback also and advantage also. The drawback is that it can occupies more space, and at the advantage is that we can easily jump or we can easily create anything and insert anything that is more easy to be inserted than to be inserted in the single linked list. Because in the single linked list we had to create a temporary node and jump it all over to the position we want to insert, but here we just have to create it and we just get the good idea of the node where our node is. Okay, so let's see how this is implemented. Okay, so first the program will start from the main function and we will ask the user to insert, delete or display. So if we want to insert, then we will ask the user where he or she want to insert, that is at the end, at the middle or at the very start. If the user want to insert at the very end, then we call this one d.insert x, that will take call the insert function. So insert function is right yes, right here. Okay, so for the insert function we will just see where our head is. So now here we will create two nodes, two pointers to the nodes, that is head and the tail, because we are creating two pointers as I said. So we will just see if our head is null. If our head is null means the same way in the linked list, in single linked list, that means our w is empty or not. If it is completely empty, then we will just take the new node's address and we just give it to the head and it will be inserted. But but if it is not empty, and if we want to insert at the very start, then what we do is we takes the head's previous address, that means the previous address of the head, and we give it to the s, that means the pointer of the node we want to create. And the node we want to create will have the address of the head, and the node we want to create previous pointer will have the address of the null. It will have the address of the null because the previous part means it will have nothing previous to it, because it is the very first element, and the next part means it will have the next head to it. That is why it will have a previous to the null. Okay, and if we want to create insert it at the very end, then in the same way we used in the head operation, the same will be done with the tail operation. The tail's next address, that means the last address, will be given to the s, that means the pointer to our node, and the pointer to our node will contain the null part because it is the very last element. That means the next will have nothing, the zero, that means it is the end of the list. Okay, and the same way position here we are creating is what. So as I told that it is very efficient to insert at a particular position because we don't have to run anything. Okay, so it just saves our time. So what we do is we take a node we want to create, we take a node we want to insert at the position, we take a counter that will tell us at what position we are, and we will go to the ahead of one position before the position we want to insert. And what we do is the node we want to insert, we just give that node's next address to the node where our current counter is. Okay, and the node our node's previous address will be given to the node where our current counter is, and in this it will the node's next address will be given to the node we want to insert, address will be given to the next of the node we want to insert. Okay, so this may seem confusing, but as we will implement it will be very easy, and this is how the insert operation will be performed. And for delete we are doing the same thing. For deleting at the front we are just incrementing the head part as we used to do in the single linked list, and for deleting at the end we are just taking the tail part and keep and decrementing it, that means taking it, moving it aside, left side, so that the right side's node will have no connection with the list. And for inserting at the operation we are doing the same thing as we have done in the enqueue part. for the just here what we have done is we have created a temporary node, and that node's address and that node pointers will have the address of the node we want to delete, and we just takes the node we want to delete, and we the node the next to it will have the address of the node which is very prior to it, and that's how we will just push the node we want to delete aside, and we delete the temporary node. So that is how the node will be deleted. And this was the W linked list. Now let's run it and see. It's asking for insert. Let's insert the element. Added is 6. We want to insert at the very end, at the very front, sorry. Then we want to insert the element, and the element added is 7. Now we want to delete it, insert it at middle position 3. So position 2 we added will be 2. And okay, sorry, this was an error. Now let's again run this. Okay, so insert the element at the very front. Okay, now again we will do an insert operation, and we will insert the element 7 at the very end. Okay, and now we will display 6 and 7. That's right, that is how it is performed. If you want to delete, then also we can do the same thing. We just delete the element from the very front, and when we will display, only 7 will be there because 6 is pulled out. Okay, so this is how the doubly linked list works. That is more efficient than single linked list of data structure. Thank you.